Hi everyone, welcome back. Naji here. In this video, we are going to understand one of the most influential computer vision architecture that is called the CLIP, and we will discuss its counterpart OpenCLIP. Unlike traditional image classification models like ResNet, ResNet, etc., that only recognize a predefined classes, CLIP can understand the relationship between the images and the natural languages. So in this video, as I said, we will cover a CLIP, OpenCLIP, and we can do some sample program using the OpenCLIP. So first let's understand what is CLIP. So CLIP stands for Contrastive Language-Image Pre-training. So traditional image classification, as I said, is trained on the fixed number of labels, right? It can be trained with a dog, cat, horse, etc. But CLIP actually changed the entire idea. So instead of learning the labels, it actually learns the relationship between the images and the natural language. So that is what is shown here. So we will have an image and we will have a natural language, and we are building some kind of a semantic relationship between these images and the natural language. So what is happening is that during the training, we are trained with the images and its caption with the millions of records, and based on that, it creates a semantic similarity record. Now let's understand how the training is happening. So basically there will be like two separate encoders. One is for the image and other is for the text. So both will be encoded. And or in other words, we will create some kind of a vectors and we will project this into the same vector space. So for example, here consider about the image encoder part. So this is the image encoder, and we will encode the image using the any vision transformer or the ResNet, and we will create some kind of embeddings. In the similar way, we will be taking a text, and we will be using some text transformers, and we will create the embedding on this embedding of this particular text. So once that is done, we will be projecting that into a space, a embedding space, and during the training, lot of like a forward and backward process, we can see that this image on the dog and the text that contain the dog will be very close region. And finally, we will use the cosine similarity, and we will take the angle between the text and image to identify the relationship between these two. So which means if they are very close to one, that means they are the identical meaning, and if they are relatively opposite, they are going the negative direction, opposite directions, and if the value is 0, the cosine similarity value is 0, then that means there is no relationship between the text and the images. Now let's understand how this zero shot prediction work, right? Now we have the model is the CLIP is trained with a lot of text and the image relationship. Then it is actually build a cosine similarity or vector space, right? So whenever we send a image, and what is happening is that we will send to a image encoder. Then based on the based on something that we have given, a dog, a cat, a horse, it will actually calculate the cosine similarity. Based on that, it will pick the it will understand what is there in the image. So even if it is not trained with a even if it is not trained with a something that is say like zebra. So we are not yet trained with the zebra on this CLIP. So even though using the similarity or vector similarity, it will able to identify that it is zebra. Now this is just to identify. So this is a difference between the traditional classifier and the zero shot classifier, and most of the things that I have already discussed. So we can see that in the traditional, we will be have like a fixed set of classes. So we will be the dog, cat, and horse. But in a zero shot CLIP classifier, we will have like an infinite number of classes are available, because we are using the vector similarity there. Then here it is rigid, cannot recognize the unprogrammed concept, but it is dynamic. It will able to identify the unrecognized or even untrained images also. So just as I said, to add the zebra, you must have a collection new labeled data, modify the architecture, and retrain the model. So earlier we have trained with the dog, cat, and horse. Later we need to identify with the zebra. Then we have to train the model with the zebra, and we have to retrain the model. Okay, but here we can to identify the zebra. Okay, so it is very simple, right? We need to have like a prompt to zebra, no architecture changes needed, no architecture changes, or the retraining is needed, because using the Cosine Similarity it will be able to identify that. That's it. Okay. Now understand, as I said, the CLIP actually developed by the OpenAI, or OpenAI is using the CLIP, and where it is using the CLIP, right? So CLIP is used by OpenAI to do the semantic image search, and also it will try to, if something is defined or created by the DALL-E, it will use the CLIP to do the cross checking with respect to the text or the prompt user asked, and also the text created by DALL-E, and it will check like how close is the image. For that also, for kind of like a verification also, we are using the OpenAI using the CLIP. Okay. Now coming to the OpenCLIP, so we know that CLIP is a proprietary kind of a thing, and we don't have does not have any access to its weight and all those things, but that's why the community has created the OpenCLIP, and they have a lot of weights are available. So I will show you like one of the weight, and we will do some kind of a sample with the OpenCLIP. So next is like where we can use that. So CLIP can be used like a zero shot image classification. As I said, it will able to do the image search, and it also can be used with the generative AI guidance. Now just consider a use case in the healthcare, right? So if I want to identify a diabetic retinopathy, okay, so what I will do, I will pass this diabetic retinopathy to our OpenCLIP, and I will ask that, okay, these are my options. Okay, a healthy retina, a retina with a mild diabetic retinopathy, a retina with a severe diabetic retinopathy, right? If I am passing these details to the our OpenCLIP model or CLIP model, it will able to identify, okay, which one is the closely matching, and based on that it will give us some score. Okay, but this is, I said, with respect to example, this may not work directly. Sometimes like we may have to do the fine tuning. Okay, so most of the case, so if it is come to the healthcare, definitely we need to fine tune it. Maybe like 1 or 2 cases it may able to predict in a correct way, but that is always true, right? So definitely if it is healthcare, don't directly go with that. So we have to fine tune the model, and once it is fine tuned, like we will able to use that in the healthcare domain also. Okay. Now in a high level, we will have a dual encoders will be there. We will project that into a space, and we have a zero shot flexibility is there, and we also discussed about the OpenCLIP, and it has to be fine tuned for a specific use cases. Okay, so this is what we discuss in a high level. Now we can see in a sample program, we will try to see how can we implement the OpenCLIP with respect to the Python. Okay, for that what we need, okay, so we need to have a OpenCLIP torch has to be installed. So here I am using the Python 3.12 version. Okay, so this is what we have. Now let me show you, okay, this is the image that we are going to identify. Okay, so here we have a dog is there, and we have a cat is there. Okay, now we need to do some kind of a import. Let me make it minimize this one. Okay. Okay. Now let's import like a few things. We need to import the torch, and we need to create the image, and we need to import the OpenCLIP. Let's do that. Okay. So here what we are going to do, we are going to use the architecture of the VIT-B32, and this is the way that I am going to use. Okay. So if you go to the OpenCLIP Git repo, we will able to see like other different models also. So let's execute this. So we will get a model is there, and we will get a preprocessor we will get. Now just take a tokenizer. So we are using the with B32 as a tokenizer. Then first what we are going to do, we are going to do the embedding, or we are going to create a tokenizer of a diagram LAN a dog. Okay, I am passing this text, and I am what we called, I am just creating the embeddings of this one. Okay, then similar to that, what we need, we have to do the same with the image also, right? So here we can see I am just opening the images, and I am doing some pre-processing with respect to these images, and I am adding just the batch also, like unused also I am using. Okay, so this is image, the image part is done. Okay, now next part is the very important thing. Okay, so here what we are doing, we are taking the image feature, right? So we have the image, and I am going to encode the images. Okay, then I am using the model dot image encode or encode image, I am passing the image. Similar way, I am taking the text. Okay, so here we have the text is there, we have a tokenized text is there. I am going to encode the text. So we have the two encoded things are there. So if you remember the architecture that we have discussed, right, we have a image text is there, we have a image encoder is there, we have a text encoder is there. Now here this statement that we are going to normalize this. Okay, it's simply we are doing the normalization here. So we will get a normalized image and we have to get the text, right, normalized text. Now what we are going to do, we are doing some kind of a matrix multiplication here. Okay, so this will give us a value between like -1 to 1. Then we are just doing some kind of a we are doing like a multiplication with 100 that converted to the in 100 range. Okay, that's it. If it's something like, if my result is like a 0.72, we will multiply with 100 and we will get a 72%. That's it. So once that is done, okay, so this part I believe understood. The next part is that we are taking the softmax. So we will take the maximum value from that and finally we will print that. Okay, that is what actually happening here. Now if you want to understand in a better way to understand this particular width, okay, I have a image representation here to give you a more clear understanding. So I am passing a image input, I am encoding it. Okay, here I am creating like 1 into d dimensional image feature. Now these are my input, right, a dog, a cat, a car and a bird. Okay, and we will be creating some text embedding or text features with respect to that. Okay, we are creating the text features on these texts. Okay, now we have to do some kind of a multiplications. For that we need to do transformation. Okay, so this is the traditional machine learning or deep learning structure that we do. Okay, so we will be multiplying with this with the each columns from this column and this column and this column and this column. Finally we will get a single row, right? So this is like 1 into 4 and 4 into 4. So finally we will get a 1 into 4, right? So we will get a 1 into 4 here, and here this will be, we will get some score. Okay, we are passing the dog here. Okay, so if you look on here, the maximum score is for coming for the dog. Oh no, this is just an example. Okay, so here it is coming as a bird, but in a real case scenario we will get maximum score with respect to the dog since we passed the dog here, but this image is little wrong. Okay, I'm sorry. So here we can see, anyway the goal is like we will get some scores here, and based on this scores we will select the maximum score. Okay, then we will have like in this case we will get the maximum score, that is the bird, but that is actually wrong with respect to this image. But I believe you guys got a like a clear understanding how this works, right? So that is what happening here. That is what happening here. We will take the images, we will encode it, we will normalize it, then we will do the softmax on it. Okay, now let's execute it. Execute it. We have the model tokenizer and we have the text. Let me see if I can print it or so. Okay, here we can see the tensor. Okay, this is the image pre-processing. Now let me do this. Okay, so here I have executed this one. Okay, now it is giving the maximum probable thing. Okay, this gives us like a 0.81. Okay, so let me look on the thing that I have sent. Okay, it is actually wrong. It says a diagram. Okay, so this is actually giving a wrong result. It says this is a diagram, but that is wrong. So let me restart it again. Let me do this. I am executing this. Let's see the result. Okay, so here also we are getting the highest score is for the first one, so 0th one. So that is we are getting for the diagram. Okay, so I don't know why it's giving for the diagram. Maybe let me change this into, oh, this is I have given some kind of a wrong here. Instead of dong I have given something different. Okay, so let me correct this. and let me do it again. I'm executing it again. Let me look on this now. Okay, see, if you look on this, we are getting the maximum for this dog, right? So I am getting the 96% of accuracy for this dog. Okay, earlier what was the issue that, okay, I have given some kind of a wrong spelling here, dong. So our system or the model will not able to identify that. So it is giving like a maximum score for the diagram. Maybe it's look like a diagram of something like this, right? That may be the reason it is giving more value for the diagram. Anyway, definitely it is not a lion, so it automatically select the diagram as a maximum score. So that was the reason. Okay. So I believe overall, I believe everybody understood about the clip and OpenCLIP, how to use that. And there are I also discussed about different use cases, right, where we can use the clip or OpenCLIP. Okay. So that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.